Imagine that we have a little toy car that's traveling on a track, and it hits a bumper and bounces back. So this is a beautiful drawing of the little toy car and the bumper. And let's suppose that the toy car is traveling to the right at a constant speed of 10 meters per second for 10 seconds. Then it hits the bumper and travels in the opposite direction at a speed of 6 meters per second for 10 seconds. And assume that its speed and direction change instantaneously when it hits the bumper. Okay, so how far did this little toy car travel? Well, now we have an interesting situation. We have negative velocity. Let's put the little picture of the toy car back up and the three conditions that we had here. And here's a graph of the velocity. So if you notice, we have a positive 10 meters per second for the first 10 seconds. And then since the car changed direction and went the other way, we have a negative 6 meters per second for the next 10 seconds. Since velocity is a vector quantity, that means that direction matters, and we're talking about one-dimensional motion, when the car hits the bumper and goes the other way, we call that velocity negative. Okay, so in this case, the total distance that the car actually traveled is 100 meters plus 60 meters. So how did I figure that out? Well, if we look at the first 10 seconds, and we imagine looking at this rectangle right here, this one that's from 0 to 10, so this one right here. So the area of this, I'll call that A1, would be, in this case, 10 times 10. So this is 10 seconds times 10 meters per second, and that's 100 meters. Then this area right here, which is this rectangle right here, I'll call that area A2. Well, A2 in this case would be 10 seconds times 6. So that would be 6 meters per second. And that gives me my 60 meters. And so when I want the total distance traveled, what I'm doing is I'm adding up 160 to get 160 meters. This includes the backtracking. This is just the distance that the little toy car traveled. Now, there's another quantity that's of interest here, and that would be the displacement. And displacement is a change in position. So in this case, we're going to look at area 1, which was 100 meters, and we're going to subtract area 2 because now we have an area that's below the axis here. We're going to consider that to be, in a sense, negative area. And so we get 100 minus 60, or 40 meters to the right. Now, displacement is also a vector, just like velocity, and so we need to indicate a direction. So when we calculate the displacement, which is the change in position, this part right here, that 40 meters, that's the magnitude, and to the right, that's the direction. So when we have negative velocities, the difference in the areas gives the change in position.